Hello students, we are going to discuss paper 4 that is based on work, energy, power and circular motion. In the first question, force is given as 2I plus 3J plus 4K. It is acting on a particle and displaces the particle by 3I plus 2J plus 5K. We want to find the work done. The definition of work done is F dot S. So we have to do the dot product over here. Multiply I with I, J with J and K with K. Here I dot I is equals to 1, J dot J is equals to 1 and K dot K is equals to 1. Where I dot J, J dot K or K dot I is equals to 0. So 3 into 2, that will be 6. 3 into 2, 6 plus 5 into 4, 20. So work done will be 32 joule. So option 3 is correct option. In second question, two vectors A and B are unit vectors. Unit vectors, that means magnitude of A and magnitude of B is 1, such that A plus 2B and 5A minus 4B are perpendicular to each other. Now, by the definition of dot product, A dot B is equals to AB cos theta, where theta is the angle between A and B. If two vectors are perpendicular to each other, then theta will be 90 degree and their dot product will be 0. We'll use this concept over here. These two are perpendicular, so the dot product will be 0. So 5 into A dot A minus 4 into A dot B plus 10 into B dot A minus 8 into B dot B is equals to 0. A dot A will be A square. Here A is unit vector, so it will be simplified, minus A dot B is equals to B dot A. So minus 4 A dot B plus 10 A dot B, it will give us plus 6 A dot B, minus 8 B square and B is equals to 1 is equals to 0. So 6 A dot B is equals to 3. A dot B is equals to 3 by 6, that will give us 1 by 2. Now A dot B is A B cos theta is equals to 1 by 2. Here A and B are unit vector, so their magnitude is 1. So we can write cos theta is equals to 1 by 2. So theta is equals to 60 degree. So angle between A and B is 60 degree. So option 1 is correct option. In the third question, a body of mass 5 kg is moved up over 10 meter along the line of the greatest slope of angle of inclination 30 degree. It is moved 10 meter along this path. We want to find the work done in doing so. Here we can use the work energy theorem. So work done is equals to change in energy. At this point potential energy was 0. At this height potential energy will be maximum. First we have to find this height h. For that we can use trigonometric identities. Sine 30 degree is equals to h divided by 10. So 1 by 2 is equals to h by 10. So h is equals to 5 meter. So work done will be gain in potential energy, that is mgh. Mass is given 5 kg. G is taken as 10 and height is 5. So work done will be 250 joule. So option 3 is correct option. In question 4, it is given that a bicycle chain of length 1.6 meter is lying on horizontal ground and its mass is 1 kg. G is given as 10 meter per second square. Now we are lifting it from one end such that the other end touches the ground. So after lifting, the situation will be like this. Here we will use the concept of center of mass. your center of mass is at this point. Initially it is lying at ground. When the chain becomes vertical, the center of mass will be lifted by height 0.8 meter. So work done is equals to changing potential energy of center of mass, that is mgh, because initially it was lying on ground. Mass of whole chain is 1, g is taken as 0, and h is 0.8. So work done will be 8 joule. So option 3 is correct option. In question number 5, we are given force and displacement graph and we want to find the work done. The area under force displacement graph will give work done. So simply we have to find the work area of this triangle. Work done is equals to half into base will be 40 minus 2 into height is 60. So work done is equals to half into 12 into 60. So work done here will be 360 joule. So option 2 is correct option. In question number 6, a body is starting from rest. So at p is equals to 0, u is equals to 0. We want to find the ratio of kinetic energy in first 5 seconds to the kinetic energy in next 5 seconds. At t is equals to 5 seconds, let's say velocity is v1, and in next 5 seconds, that means total time will be 10 seconds, velocity is v2. First we'll find v1. v1 is equals to u plus et. U is 0, so v1 is equals to acceleration, let's say it is e, and time is 5. So v1 is equals to 5a. Starting from rest, v2 is equals to u plus et. Your total time will be 10 seconds, so v2 will be equal to 10e. Now, kinetic energy gain in first 5 seconds, let's say it is k1, will be half m v1 square minus half m u square. Here u is equals to 0, so k1 will be half m v1 square. v1 is 5a, that will be 25e. Now kinetic energy gained in next 5 seconds will be half m v2 square minus v1 square. So k2 will be half m v2 is 10a, that will be 100e square, minus v1 is 5a, that will give us 25e square. So k2 is equals to half m 75e square. Taking ratio of k1 and k2, it will give us 25 by 75, that is 1:3. So option 4 is correct option. In question 7, a simple pendulum is given whose length is 1 meter. The mass of bob is 100 gram, that is 1/10 kg. Now the bob is drawn aside from equilibrium position so that the string makes the angle 60 degree with vertical. We want to find the kinetic energy when the bob is released from this position and it reaches the equilibrium position. In this case, we will use conservation of energy. As there is no external resistive forces acting on the system, we can use conservation of energy. For reference, at this point we will take potential energy as 0. So at this point, gain in potential energy will be equal to kinetic energy at this point. So potential energy at point 1 is equals to kinetic energy at point 2. To find the potential energy at point 1, we have to find the height from this base. If this length is L, then this component will be L cos theta. Let's say this point is O, this point is A, this point is B. So H is equals to AB is equals to L minus OA. and we can write OA is equals to L cos 60 degree. So height will be L minus L cos 60 degree. Here length of pendulum bob is given 1. So 1 minus 1 into cos 60 is half. This will give us height half. So potential energy at 1 is equals to mgh. Here mass is 1 by 10. G is 9.8 and h is 1 by 2. So it will give us 4.9 joule. That is the kinetic energy at 2. So option 1 is correct option. In question 8, specific gravity of liquid is given 0.8. Specific gravity is the relative density, that is 0.8. Relative density is equals to density of liquid upon density of water. We know that density of water is 1000 kg per meter cube. So density of liquid will be 800 kg per meter cube. We want to find the kinetic energy per cubic meter. The formula of kinetic energy is half mv square. Here density of liquid is equals to mass upon volume. So we can write mass is equals to density into volume. Here it is asked for 1 cubic meter. So we'll take V is equals to 1 meter cube. 2 into mass is equals to density into volume. Density is 800, volume is 1 into speed, that is given 2 meter per second square. So answer will be 1600 joule. So option 2 is correct option. In question number 9, a body of mass 2 kg is projected with an initial velocity of 5 meter per second along a rough horizontal table. We want to find the work done by the frictional force before it is brought to rest. It is brought to rest, that means its final velocity is 0. We will use work energy theorem. According to it, work done is equals to changing kinetic energy. Here work done will be final kinetic energy minus initial kinetic energy. As body is finally coming to rest, final kinetic energy will be 0 minus half mu square. So work done will be minus half, mass is given 2 into u square, 25. So work done will be 25 joule. So option 4 is correct option considering the magnitude. In question 10, it is given that if a bullet is passed through a trunk, it loses 1/4 of its kinetic energy while traveling a distance of 5 centimeters. We want to find after traveling further how much distance the bullet will come to rest. That means its kinetic energy will become 0. Let's say a bullet is entering the trunk with kinetic energy k and initial speed u. It will emerge out after traveling a distance of 5 centimeters with kinetic energy 3k/4. Now, the final kinetic energy half mv square is equals to 3/4 of initial kinetic energy half mu square. This half m will get cancelled out. So v square is equals to 3/4 u square. We'll use third equation of motion. V square is equals to u square plus 2as. Final velocity is 3/4 u square is equals to u square plus 2 into a into distance is 5. This will give us minus 1/4 u square is equals to 10a. Let's see. If bullet is entering with speed u, after traveling x distance, it is coming to rest. That means final velocity will be 0. Again, we'll use this equation. V square is equals to u square plus 2as. Final velocity is 0. Initially is u square plus 2ax. So minus u square is equals to 2ax. This is equation 1 and this is equation 2. Take the ratio. So 1/4 is equals to 10a divided by 2ax. So x will be 20 centimeter. So after traveling total 20 centimeter, the bullet will come to rest. So further it will travel 20 minus 5, that is 15 centimeter. So option 4 is correct option. In 11, a body of mass 0.5 kg is moving in a straight line with velocity is equals to a x power 3 by 2, where a is 5. We want to find the work done by force during the displacement from x is equals to 0 to x is equals to 2 meter. Here, if we use work energy theorem, then problem will be simplified. According to work energy theorem, work done is equals to change in kinetic energy, that is final kinetic energy minus initial kinetic energy, is equals to half mv square minus half mu square. Final velocity is at x is equals to 2. So put this value in this equation, we'll get v is equals to a is 5 into x, that is 2 power 3 by 2. Initial velocity at x is equals to 0. Put x is equals to 0 in this equation, so u will be 0. Put both the values in this equation, so work done will be half into mass is 0.5, that is 1 by 2 into v square, that is 5 into 2 power 3 by 2 whole square. Simplifying this, we will get the answer 50 joule. So option 1 is correct option. In question number 12, a body of mass 1 kg is moving initially with speed v1 is equals to 2 meter per second. It enters a rough path ranging from x is equals to 0.1 meter to x is equals to 2.01 meter. Retarding force acting on the block is given by minus k by x, where x is between 0.1 to 2.01 and value of k is 0.5 joule. We want to find the final velocity, let's say it is v2. Again we will use work energy theorem. So work done is equals to final kinetic energy minus initial kinetic energy. So kf minus ki is equals to, here force is variable, so we'll use integration f dot dx, x ranging from 0.1 to 2.01. The value of f is minus k by x dx, 0.1 to 2.01. Value of k is 0.5, that is constant, minus 0.5, 1 by x dx, 0.1 to 2.01. Integration of 1 by x dx is ln x, so minus 0.5 ln x, 0.1 to 2.01. So minus 0.5 ln 2.01 minus ln 0.1 minus 0.5. Applying log property, ln 2.01 divided by 0.1, this will give us minus 0.5 ln 20.1. We can find this value with the help of log table. It will be 3, so minus 0.5 into 3, that will be minus 1.5. That is k final minus k initial. Now k final is half mv square minus k initial is half mu square is equals to minus 1.5. Mass of the object is 1 kg and object was initially moving with speed 2 meter per second. So half mass is 1 into v square minus half mass is 1 into u square, that is 4, is equals to minus 1.5. So half v square is equals to 2 minus 1.5. So half v square is equals to 0.5. So v is equals to 1 meter per second. So option 2 is correct option. In 13, a tank of size 10:10:10 is given. It is full of water and built on the ground. We want to find the potential energy of this water. For this kind of problem, we will always use the concept of center of mass. Here the center of mass of this water will be at height of 5 meters from the object. Let's say mass of the water is m. Density is equals to mass upon volume. So mass of the water will be density, that is 1000, and volume of whole tank is also 1000 meter cube. So mass is 10 power 6 kg. Potential energy is mgh. Mass is 10 power 6. G is given 10 and h is 5 meter. So potential energy is 5 into 10 power 7 joule. So option 1 is correct option. In question number 14, this angle of inclination is given 30 degree. This height is 6.3 meter and this height is 3.8 meter. A block is sliding down with initial velocity 0 and comes to point B. We want to find its velocity at point B. Here no external resistive force is acting, so we can use conservation of energy. From point A to B, it is losing its potential energy and gaining some kinetic energy. So kinetic energy at B is equals to loss in potential energy. Kinetic energy at B will be half mv square and loss in potential energy will be mg. The height reduced will be, initially it was at height 6.3 meter, now it is at height 3.8 meter from the ground. This m will get cancelled out, so v square by 2 is equals to, g will be taken as 9.8, 6.3 minus 3.8, that will be 2.5. Simplify this, v will be 4.9 meter per second. In question number 15, it is given that a stone of mass m, initially at rest, so u is equals to 0, is dropped from height h and strikes the surface of the earth with speed v. If the gravitational force acting on the stone is W, then which of the following identities is correct? Here we are not considering air resistance, so again we can use conservation of energy. That means loss in potential energy is equals to changing or gaining kinetic energy. Potential energy loss is equals to mgh. Change in kinetic energy is half m v square minus half m u square, but here initial velocity is 0. Here mg is replaced by w, so wh is equals to half m v square. So we can write half m v square minus wh is equals to 0. So option 3 is correct option.